Welcome to Bureau of Indian Standards, Bangalore Branch Laboratory. In this video, we will demonstrate the testing of aluminum alloy stranded conductors as per IS 398 Part 4. Aluminum stranded conductors are used in the transmission and distribution system to transport electrical energy from generating stations to end users. These systems can be overhead or underground, with overhead systems being preferred due to low cost and other advantages. Different types of conductors used are aluminum standard conductors as per IS 398 Part 1, aluminum conductors galvanized steel reinforced as per IS 398 Part 2, aluminum conductors aluminized steel reinforced as per IS 398 Part 3, aluminum alloy stranded conductors as per IS 398 Part 4. Aluminum alloy stranded conductors are homogeneous conductors and are also known as all aluminum alloy conductors. They are made of high strength aluminum magnesium silicon alloy with different variants of electrical grade alloys. The following tests on aluminum alloy stranded conductors will be demonstrated one by one. Diameter test as per IS 398 Part 4, Class 7.1.1, Table 1. Resistance test as per Class 12.4, Table 1. Breaking load test as per Class 12.2, Table 1. Elongation test as per Class 12.3. Lay ratio as per Class 3.1.4. Stranding as per Class 9. The first test being demonstrated is diameter test. The diameter of a conductor directly impacts its cross-sectional area, which in turn influences its electrical conductivity. Maintaining proper diameter ensures efficient current carrying capacity through the conductor. The equipment used for this test is digital micrometer. Procedure: the nominal diameter of the sample taken up for testing is 3.15 mm. Ensure the sample is straight. Length of the sample required is approximately 1 meter taken from standard conductor. Mark the measurement points at random places at the center and at the two ends of the test specimen using marker. The diameter is the average of two measurements taken at right angles at the same cross section. Similarly, readings at three different cross sections are obtained. The final diameter is the average of the readings obtained at three different cross sections. The diameter of the sample tested should be within the range specified in Table 1 of IS 398 Part 4, which is shown on the screen. The next test being demonstrated is resistance test. Every conductor has inbuilt resistance which resists the flow of electricity. This resistance causes heating and leads to wastage of power transmitted through it, which in turn reduces the efficiency. The equipment used for this test are digital micro ohm meter, thermometer, test bench with terminals and clamps. Procedure: the diameter of the sample taken up for testing is 3.15 mm. Ensure the test specimen selected is free from visual defects. The length of the sample required is approximate 0.7 meter. Connect the conductor ends to the test bench terminals with the aid of clamps. The electrical resistance of test sample with a length of 0.5 meter shall be measured at ambient temperature. Note the ambient temperature reading using the thermometer and also the resistance at the ambient temperature in milliohms by using micro ohm meter. The readings obtained are displayed on the screen. The value obtained will be in milliohm per 0.5 meter. This value should be converted to ohm per kilometer as per the requirement of the standard. In addition, as the measurement is not taken at 20 degrees centigrade, apply a temperature correction factor using the standard temperature coefficient of resistance for aluminum alloy. The formula used for correction factor is R20 is equal to RT into 1 by 1 plus alpha into T minus 20. The resistance corrected at 20 degree centigrade shall not be more than the maximum values specified in table 1 of the standard, which is displayed on screen. The third test being demonstrated is breaking load and elongation test. Breaking load is crucial for ensuring that the conductor is strong enough to handle the mechanical stress it experiences during its period of operation, including different wind, snow or load conditions in the field of operation. The minimum breaking load for different sizes of aluminum alloy stranded conductor are specified in the standard IS 398 Part 4. Elongation test measures how much the aluminum alloy can stretch before breaking, which is important to ensure that it does not break under heavy load or severe weather conditions. This test determines the material strength, ductility and overall quality. The equipment used for this test are universal tensile testing machine, steel scale. Procedure: the diameter of the sample taken up for testing is 3.15 mm. The length of the sample required is approximate 300 mm. Initial gauge length of 200 mm is marked on the sample. The sample is then mounted between the jaws of the UTM. While mounting, it is ensured that the ends are properly clamped to avoid slipping during the test. The rate of separation of jaws should be between 25 mm to 100 mm per minute. The UTM should be programmed as per the sample size taken up for testing by entering the conductor diameter and rate of separation of 50 mm per minute, which is fixed for the sample under test. Increase the load gradually until the sample breaks. This value will be automatically recorded in the system. The breaking load obtained should be equal to or greater than the minimum value specified in table 1 of IS 398 Part 4, which is displayed on screen. After breakage, the sample should be removed from the jaws of UTM and placed on a flat surface. Join the broken ends of the specimen together and measure the final gauge length using a steel scale. The formula for elongation percentage is final gauge length minus initial gauge length divided by initial gauge length into 100. Passing criteria for elongation is elongation must be at least 4% as per IS 398 Part 4. The next test being demonstrated is lay ratio. The lay ratio will determine the flexibility and overall performance of the conductor and how easily the conductor can bend and resist the fatigue. Procedure: the length of sample required for this test is approximate 1 meter of stranded conductor. Measure the axial length of one complete turn of the helix formed by individual wire of a stranded conductor. The diameter of a stranded conductor is the average of two readings taken at right angles to each other. The lay ratio is calculated using the formula axial length of one complete turn of the stranded helix divided by external diameter of stranded conductor. The passing criteria is that lay ratio must be between 10 and 14 as specified in IS 398 Part 4. The next test being demonstrated is stranding. Stranded conductors are most widely used than solid conductors because of their low resistance, larger surface area and flexibility. They have more current carrying capacity even for smaller diameters when compared to solid conductor. Procedure: the wires used in the construction of a stranded conductor should be evenly and closely stranded. The direction of lay of strands can be either right-handed or left-handed. With right-handed lay, the wire shall conform to the direction of central part of letter Z. With left-handed lay, the wires shall conform to the direction of central part of letter S. In both the cases, the conductor should be held vertically.
Quality of aluminum alloy stranded conductors is gauged by testing these parameters as per IS 398 Part 4. Thank you for watching.